Hello guys, welcome to Pepcoding, and now we are going to discuss the next question, that is complete binary tree insert. Okay, so in this question we have been given one complete binary tree, and what we have to do is we have to insert the element in that complete binary tree. Okay, so let's see the question first, and then we are going to discuss the approach of this. Okay, so our question is CBT, that is complete binary tree. So first we are going to understand what actually the complete binary tree is. Okay, then we are going to come into the actual part. Okay, actual question part. Okay, so complete binary tree is that tree in which all the older levels are filled. Okay, which all the lower levels are completely filled. Okay, that means all older levels are completely filled. And what is the next condition for CBT is all the nodes to the left are completely filled. Okay, so for CBT these two conditions are mandatory. So let's understand with the help of example what actually these conditions are. Okay, suppose this is our tree, one is there, then in the next level, that is 2, 3 is there, next in the next level, that is 4 is there, and 5 is there. So is this tree is a complete binary tree? Yes, this is a complete binary tree. Why? Because all the older levels, that is this and this, are completely filled. Okay, and all the element to the last node, to the left of the last node, is also completely filled. Okay, so let's understand for some more examples, that is 7, and suppose this there is 8, and suppose there is 9. Is this a complete binary tree? Let's see. So when we see this condition, that means all the levels are completely filled. That is true, but the from the last node to the left side it is blank. That means we can insert one node in this place. So this is not a complete binary tree. If there is any vacant place to the left side, then it is not a complete binary tree. So for complete binary tree we have to insert 9 to the left side. Okay, so first it is going to fill the left side, then it is going to fill the right side. So these are some rules for complete binary tree. Okay, so let's see further. Suppose 9 is there, 10 is there. So is this a complete binary tree? Yes, it is a complete binary tree. Is this a complete binary tree? No, because the left is vacant. Okay, so this is not a complete binary tree. So what we have to do is we have to insert 11 to the left side, and then we have to insert the next element to the right side. So these are some rules for complete binary tree. So let's understand again. So for complete binary tree, what we have to do, first the levels will be filled, and then to the last node we have there should be no vacant places. Okay, so all the left side nodes are completely filled. So these both conditions are the for the complete binary tree. So now I think we have understood what actually the complete binary tree is, and now let's move to the question part. Okay, so now we are going to understand what actually the question is. So suppose we have been given one complete binary tree. Suppose I have taken the one example, that is 1, 2, 3 and 4, 5, 6, 7, 8, 9, 10. Suppose this is example, and what we have to do is we have to insert one element. Suppose we have to insert 12. Okay, so what we have to do is we have to insert that element, so the 12 should be inserted in this position. So this is what actually we have to do. We have to do the insertion in the complete binary tree. But what is the main thing is we already know how to insert a node into a tree. We already had done this, but the important part in this question is that we have to do this operation in constant time. Okay, so the time should be constant. So this is the main part of this question. That means we have to take the constant time to achieve that operation. Okay, so now we are going to understand like how can we do this. So before doing this, first what I'm going to do is I'm going to take one test cases, and then I'm going to understand this, how can we achieve this. So let me take the test cases. So this is our test cases, and let me take this and let's understand it now. Okay, so these are the operations. So what we have to do, we have to do the three operations. So these are the operations. So these are the number of operations, that is CBT, insert and get root. In insert operation, what we have to do, we have to insert that particular node. So we have to create the node and we have to insert in this tree, and this is actually our tree. So we don't have to create the tree. Okay, so tree is already created in our snippet. Okay, so what we have to do, we have to simply do the insertion part. So we have been given three things, that is one CBT inserter, constructor, and the second thing is insert, and the third thing is get root. So we have to implement these three things. This is a simply constructor in which we have been given root, and insert we have been given val. Okay, so in CBTInserter, that is simply a constructor. So if we want to use this constructor, so we can use this. And in insert, what we have to do is we have to write the code for insertion. Okay, so we have to insert in this particular tree. Okay, so we have to insert the node in this particular tree. And the third thing is, that is get root. So what we have to do is we have to return the head. Okay, so let's see for this case, for this default test case. Okay, so first I'm going to create this tree, that is 1 2 3 4 5 6 7. So we have constructed one tree and we have been given this root. Okay, and what we have to do is we have to insert 8 over here. So where the 8 is going to insert, 8 is going to insert in this position, so to the left side. So this is the point where we have to insert. And what we have to return in insert, see, inserted in 4, that means we have to insert the parent node where we are going to insert the element. Okay, so we have to insert in 4th node. Okay, so we have to insert this particular value. Okay, so this is what we have to return in case of insert, while inserting. Suppose we have to insert 10. So what we have to return, we have to return 4. Okay, suppose the next operation is again insert, that is we have to insert 20 over here. Okay, so what I'm going to do is I'm going to add 20 over here, and now we have to return 5 because we are inserting in this node. Okay, so this is actually what is the demand of this question. Okay, and in get root, what we simply doing, we are simply returning this root element and it is going to print our tree. Okay, so this is what we have to do. So now let's see how we are going to achieve this problem in constant time. So this is the main part, that is we have to achieve our insertion in a constant time. So let me take one tree. So I'm going to take one tree, that is 1 2 3 4 5 6 7 8 9. Suppose this is our tree. Now what we have to do is we have to do in constant time. So we have to use the level order. Okay, and what I'm going to do is I will take one variable. The variable name is NIP. And what is NIP? NIP is actually the next insertion point. Okay, so NIP means NIP is a variable of a node type, of TreeNode type, and it is always pointing to that node in which we have to add our node, our new node. Okay, so in this case NIP will point to the 5 because our next node is going to insert in this position. Suppose there is already 2 child. Okay, now NIP is going to point this node. Okay, so what we have to do is we have to update our NIP. So we are going to do this updation in place of constructor. So we are going to use our constructor, in which what we will do is we are going to update our NIP value. Okay, so now in when we will create one object, so our NIP is going to point in this position. And while insertion, what we will do is we are simply going to add the child. Okay, we are simply going to add the node into our NIP, and we are also going to update our NIP side by side. Okay, so this is what we have to do. So simply what I'm going to do, I'm going to tell you how we are going to update our NIP. So for this, what we are going to do is I am going to traverse the level order. Okay, so we have already seen how to traverse the level order. So I'm going to travel a level order. Okay, and then I'm going to find out our NIP. So if any particular node doesn't have left child or else right child, then we have found our NIP. That means the next insertion point. So in that particular case, our next insertion point will be 5. Okay, so we simply have to find our NIP, and in insert function we are simply have to update, simply have to attach a new node of that particular value, and we are also going to achieve update our NIP value also if it is going to update. Okay, so let's see. So how we are going to do? So for this we have to use our level order. Okay, so for level order we already know that we use the queue. Okay, so we already know this. So we have to use the queue, and this is our root element. So first what I'm going to do, I'm going to push the root element into our queue, and then I'm going to traverse. Okay, so I will use one while loop for traversing, and first I'm going to pop this. I'm going to store this node into one variable. Okay, and if I'm going to check it, if that top node top of left is not equal to null, it is not equal to null, then what we are going to do, we are going to push the node into our queue. Okay, so the left is not equal to null, so we are going to push it. Again I'm going to check for the right also for this particular node. Again it is also not equal to null, then we are going to push 3 over here. Okay, we are going to add the right element also, right node also. Then what I'm going to do, in the second iteration I'm going to check for this. I will pop this element. Okay, now I'm going to check for this case. So if 2 of left is not equal to null, yes, it is not equal to null, then we are going to add the node into our queue, and then I'm going to check for the right side. So right is also not equal to null, then I'm going to add this particular node to our queue. Okay, then in the next iteration it will point to 3. That means we are going to pop this, and now our top is actually this element. Okay, so now I'm going to check for this case. So left is null or right is null, so both of them are not null. So what we are going to do, we are going to push 6 and 7 into our queue. Okay, then our top is going to become 4. So what we are doing, we are simply doing our level order traversal. Okay, so we have already done the level order many times, so I think you have this idea about this. Okay, so now I'm going to check for the 4. So left is not null, so we are going to add that node, and right is not null, then we are going to add that particular node. Okay, now our top will become this 5th element. So now our top is this, pointing to this element. Now I'm going to check for this. So if the top is equal to null, that means now we have find our insertion point. Okay, so next node is going to insert in this particular position. So now in this case we have found our NIP. Okay, so this is our actually the node where we have to insert our next node. Okay, so what we will simply do is we will simply mark this position, this particular place as an NIP, and I'm going to break it. Okay, so let me highlight this NIP. Okay, so now we have found our NIP, and now I'm going to break in this case. Okay, so now we have done our constructor part. Okay, so now this particular code we are going to do in our constructor. Now we already have our NIP, and now we are going to insert the next value, that is we are going to insert 10. Okay, so there will be two cases for insertion. There will be two cases. So we are having our NIP value. Okay, so we are having one NIP value. So there will be two cases. Suppose 5 is there. Okay, and the second case is its children is null, which is in this case when you will see it, the both the children are null. So the second case is if any one children is not null, that is 5, and suppose the 10 is here. Okay, so this is the second case. So there will be two cases. So if the NIP have no children, or else it has one children. The two children are never be possible in case of NIP, because NIP will only point to that particular node where it has where we can insert any particular node. Okay, so it is only pointing to that node where we can insert any node. So now our NIP is pointing to the 5. So now we have two cases. So let's see for both of the cases. Now we are going to insert the 10. Okay, so if we have to insert the 10, so first we are going to check for NIP. We are going to directly check for NIP. Okay, so now we already know our next insertion point. So we have to insert in 5. Okay, so first what we are going to do is we are going to check for left side. So if NIP of left is null, that means our NIP will only remain the same, because we have one vacant place. Okay, because we have one vacant place. Suppose we have inserted to the left side, but we have the vacant place to the right side. So we are not going to change our NIP. Okay, so NIP, we are not going to change it. But in this case, suppose we have to insert 11 over here. So we will insert 11, and now we have to change our NIP, because our NIP will become this place. Okay, if we have inserted both the child. So in this case, we have to change our NIP. Okay, so we also have to update it side by side. Okay, so when we are doing the insertion, so we have to insert the node, as well as we also have to update our NIP. Okay, so let's see for this case. So now we are going to insert the 10. Okay, so we are simply first we are going to check for NIP of left, which is null. So we are going to add a new node to the right side, to the left side, sorry. 10 is going to insert here. It is going to show like this. And what we are, the second step is we have to insert it into the queue. Okay, we have to add that particular node into our queue. Okay, suppose we have to insert 11. Okay, now this is our second case. Okay, that we already have one particular node. So if left is null, which is false, so we are going to for the else condition, that is the left is not equal to null. Then in that case, what we are going to do is we are going to attach a new node to the right side, and we are going to add that element to the right side, and we have to shift our NIP. That means our next NIP will become, our next NIP is going to become this topmost element of the queue. Now this is our NIP. That means if I am going to show you here, now it is going to point out in this position. Now this is our new NIP. Okay, so in right side, if its left is not equal to null, then in this case we have to change our NIP. Okay, so this is completely the how we are going to do our insertion, and we have already seen like we are achieving this this operation in a constant time. Okay, so now I think it is clear. So now we are going to see our coding part, and then let's understand this. So what we have to do is we have to code this in C++. Okay, so I've opened the C++ editor, and now we have to implement these three things. Okay, that is CBTInserter constructor, and the second thing is the insert operation, and the third thing is get root operation. And in CBTInserter, what we were doing is we were updating our NIP, and in insert we were inserting element. Okay, so we were inserting element, and next what we were doing is we were updating our updating our NIP. Okay, and the third function, that is we were simply returning the head. Okay, so we were simply returning the head. So how we are going to update our NIP? So for this we have to use the level order, and for level order we have to use the queue. So for queue of type TreeNode, so we are simply adding the TreeNode into our queue. So QUE, and the second variable which we are going to take is NIP. So TreeNode NIP, and the third thing which we are going to take is the head. So TreeNode. Okay, so these are the three things which we are going to take. And now what we were doing is we were updating our NIP. Okay, so for this what we will do is we are going to traverse the level order. So for level order, first what we have to do, we have to add the root element into our queue. So first I'm going to add the root into our queue, and then I'm going to use a while loop, an infinite while loop. Okay, and when we'll find our NIP, then we are simply going to break it. So for this I'm going to use a while loop, a infinite while loop. That means we are going to use the true over here. Okay, and now I'm going to update our NIP. So how we are traversing? So first I'm going to pop the element, and now I'm going to check whether it is null or not, whether it has children or not. If it is a children, then we are simply pushing the children into our queue and checking for the its children. Okay, so let's see it. So we have already done the same thing in level order traversal. Okay, so TreeNode. So I'm going to store the element, storing the topmost element. Okay, so q dot front. Okay, now we can able to get the front element, and then we are simply popping it. Now we have popped that element. So now we have this value, that this node 1, and now we are going to check for the left side as well as for the right side. So first I'm going to check for the left side. If top of left is not equal to null PTR, then what we have to do? If it is not null, then we are simply adding this element into the queue. Okay, then we are q dot push. What we have to push? Top of left. Okay, so we are simply pushing the element into the left side. Okay, so I have used the wrong method for adding, so we simply use the push. So now we have added the push the left child. Else, suppose our left is null, that means we have found our NIP. Okay, so if our left is null, that means our NIP is this topmost element. Okay, so our topmost element will be NIP. So NIP equal to top. Okay, so this is how we are going to find our NIP, and when we will find our NIP, we are going to break this loop. Okay, the same thing is going to happen for the right side also. So we have copied the same thing. So top of right, we simply rename this to the right, and we have done the same thing. Okay, so now we have found our NIP. Okay, before this I forgot one step. I have to update our head. Okay, that is pointing to the rootmost element. Okay, so now I have found our NIP. Now what we have to do, we have to insert this. Okay, so now we have our NIP, we know where we have to insert the element, and now we have to simply add the element, and this is a constant time. Okay, so we are doing this in a constant time. So now we have two cases, that is our NIP of left is null, or else NIP of left is not equal to null. Okay, so we are having these two cases, and in the first case we don't have to update our NIP. In the second case we have to update our NIP, and this we have already discussed. Okay, so and the next thing what we have to return is we have to return our NIP value. That means suppose we are inserting in this node, Suppose we are inserting in this node, so what we have to return? We have to return 5. Okay, so if you are hitting this case, then your NIP is lost. Okay, your older NIP is going to lost. So first I'm going to do is I'm going to store this value. Okay, so first I'm going to store this value. So int NIP_val is equal to NIP of val. Now I've stored this value, and now I'm going to use the two cases. That is, if NIP of left is equal to null, okay, then this is our first case. Else this is our second case. Okay, so if our NIP of left is equal to null, that means this is our this case, and if our NIP of left is not equal to null, that means this is the second case. So if NIP of left is equal to null, that means we have to attach our new node to the left side. So we will simply attach the new node, new TreeNode to the left side of value val. And now the next thing which we have to do is we have to also add that particular element into our queue to maintain our queue for level order traversal. Okay, so queue dot push NIP of left. Okay, so we have also maintained our queue. Okay, so now we have done this. Now we have to handle the second case. So for second case, we have to do the same thing also. We have to attach a new node. So we have attached to the new node to the right side, and I'm going to push it into the queue also. NIP of right, and the next thing which we have to do is we have to update our NIP. And what is our NIP? NIP is our topmost value in the queue. Okay, see, like in this case our NIP was become 6, that means topmost value in the queue. Okay, so NIP is equal to queue dot front, and I have to pop the element also. Okay, so we have completed this also, and in the end we have to simply return the NIP of val. Okay, so we have completed insert, and in the third case we have to simply return our head, that is the root element. So let me run it now. So it is running, it is inserting in the 4th position. Suppose, let me take some bigger, 7, 8, 9, and I'm inserting 10. Okay, so let me run this, whether we are achieving our full tree or not. So we are achieving our full tree. So thank you guys for watching this video, and we will meet you in the next video.